This is Go Math lesson 13.4. It's on statistics and probability. The standard is 6.sp.5c. It's on measures of variability. The essential question is, how can you summarize a data set by using range, interquartile range, and mean absolute deviation? A measure of variability is a single value used to describe how spread out a set of data values are. The mean absolute deviation is a measure of variability. In gym class, the students recorded how far they could jump. The data set below gives the distances in inches that Manuel jumped. What is the mean absolute deviation of the data set? So find the mean absolute deviation. Step 1, find the mean of the data set. So to do that, you add the data values and divide the sum by the number of data values. So they have 54 plus 58 plus 56 plus 59 plus 60 plus 55, and then I'm going to divide it by 1, 2, 3, 4, 5, 6. And so I'm going to put this up here so I can actually line it up. So let's do 6 plus 4 is 10, 8 plus 9, 17 plus 10, 27, 32, 5, 10, 15, 20, 25, 31, 32, 33, 34. So 342, and then I'm going to divide that by 6. So that's 57. So now my mean is 57. Step 2, find the distance of each data value from the mean. So I'm going to subtract the lesser value from the greater value. So my data value was 54. So 57 minus 54 is 3. They did that one for us. 58 minus 57 is 1. 57 minus 56 is 1. 59 minus 57, 2. 60 minus 57, 3, 57 minus 55, 2, and then it says add the distances, so I'm going to total these distances. 12, step 4, find the mean of the distances. So it says divide the sum of the distances by the number of data values, so it's going to be 12 divided by 6, which is 2. So the mean absolute deviation of the data is 2 inches. So now we're going to talk about another concept called range. So range is the difference between the greatest value and the least value in a data set. And then interquartile range is the difference between the upper quartile and the lower quartile of a data set. Range and interquartile range are also measures of variability. Example, use the range and interquartile range to compare the data sets. The box plots show the price in dollars of the handheld game players at 2 different electronic stores. Find the range and interquartile range for each data set. Then compare the variability of the prices of the handheld game players at the 2 stores. So store A, it says calculate the range. Find the difference between the greatest and the least values. So as you can see, my greatest value is 150 and my least value is 24. So I'm going to go 150 minus 24. So 126. The range for store A is 126. Calculate the interquartile range. So to find the interquartile range, you find the difference between the upper quartile and the lower quartile. So my upper quartile is 72 and my lower one is 48. So 24. The interquartile range for store A is 24. Now I'm going to do the same thing for store B. So my greatest value is 120, my least value is 30, so 120 minus 30, so 90. So the range for store B is 90. Now I need to find my interquartile range. So my upper quartile is 100, my lower quartile is 42. So I'm going to go 100 minus 42. So 58. The interquartile range for store B is 58. So store A has a greater range because 126 is larger than 90. But store B has the greater interquartile range because the interquartile range was 58, whereas this was 24. Okay, I'm going to do a few more problems for you. So question 1 says, find the range and the interquartile range of the data in the box plot. So it says for the range, find the difference between the greatest and the least values. So my greatest value, 19, minus my least value, 7. So that'll be 12. So my range is $12. For the interquartile range, find the difference between the upper and the lower quartiles. So my lower quartile, 10, 11, 12. And my upper quartile is 15. So 15 minus 12 is 3. So my interquartile range is $3. I'm going to do 2 and 3. And then if you have questions, you can ask me on the classroom. So for this one, it says find the mean absolute deviation for the data set. So the heights in inches of several tomato plants. So to do this one, I'm going to do it on another piece of paper because I have to find the mean of my data, and then I have to find the deviation from the mean and then divide that. So I have 16, 18, 18, 20, 17, 20, 18, and 17. So I have 8 and 8, 16, 7 and 7, 14, and 8 and 6, 14. So 8 and 6, 44. So I'm going to carry my 4. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 144. Then divide that by how many things I have in my set. So it's 1, 2, 3, 4, 5, 6, 7, 8. So 18. Okay, so my mean is 18. So now I have to find the difference from my mean to all my different data points. So my first data point was 16, so 18 minus 16 is 2. My second one is 18, 18 minus 18, 0. My third one's 18, 18 minus 18, 0. My fourth one is 20 minus 18, which is 2. Then it's 18 minus 17, which is 1. Then it's 20 minus 18, which is 2. Then 18 minus 18, 0. Then 18 minus 17 equals 1. Then I need to add all these up. So 2, 4, 6, 7, 8. And then I have to divide by however many I have. So I have 1, 2, 3, 4, 5, 6, 7, 8. 8 divided by 8 is 1. So that is my mean absolute deviation. So 1 inch. I'm going to do one more like that. So number 3 says the times in seconds for students to run one lap are 68, 60, 52, 40, 64, 40. So 8, 10, 14, 6 times 1, 2, 3, 18, 18, 18, 19, 20, 21, 22, 23, 24, 25, 26, 31, 32. So 324 divided by 1, 2, 3, 4, 5, 6. So 54. So 54 is my mean. And now I have to find out how far each of my data points are from that. So I have 68 minus 54. So 14. Then I have 60 minus 54. Then I have 54 minus 52. 2. Then 54 minus 40, which is 14. Then I have 64 minus 54, 10. Then I have 54 minus 40, 14. Now I have to add these up. So 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 2, 3, 4, 5, 6, 60 divided by 1, 2, 3, 4, 5, 6, so 10. So my mean absolute deviation is 10 seconds. If you have any questions, leave them on the classroom.